What is phenol? We have to see it first. That is, the structure of phenol is like this. It is one alpha H2 of benzene is replaced with our hydroxyl group. So how can we prepare it? That is, if we want to prepare it from benzene, that is, in first step we have to give this reagent, that is concentrated H2SO4, okay, in 100 to 120 degrees Celsius. Okay, if we give it, what does it give us? It gives us SO3H. Okay, now we give it this NaOH solution. So the H of SO3H will be replaced with Na. Now from that we heat it again at more temperature than 300 degrees Celsius in NaOH. So then it gives us O Na in place of the SO3 Na. Now from that, if we give it a acid, that is our HCl, okay, so what does it give us? The Na will be replaced with hydrogen and it gives us phenol. Okay, now there is a second reaction, that is our from benzene diazonium chloride. Now it is very easy, that is, this is our benzene diazonium chloride. Okay, so if we just boil it, okay, so we will write it like H2O heat boiling water, so it will give us phenol like this. Okay, it is a simple reaction. You just have to remember the reagent, that is our boiling water, so it will give us what? Phenol. Now from chlorobenzene, now this process where we derive our phenol from chlorobenzene, it is called our Dawes process. Okay, so what happens, you have to remember the reagent here because that is very important. Okay, they will just give you that, ask, they can ask you that only the reagent, so you just have to remember it. That is our saturated Na2CO3. Okay, also silica gel and excess pressure, this is very important, excess pressure. Okay, and what will be the heat? That is our 400 degree Celsius. So sometimes we take it 450 degree, this varies. So it gives us phenol and the process is to be called our Dawes process. So fourth is our from cumin. So this is a very important reaction because the individual steps come in it and they ask you the name of the molecules or the compounds formed in each step. So you have to remember this reaction very carefully. So it is very important. You can mark it also. Okay, so let's see what happens here. That is, what is cumin? Let us see it first. That is, cumin is like this. Okay, if this benzene ring has this group in place of one of its hydrogen, so we will call it cumin. So let's write it. It is our cumin. Now we are oxidizing it. That is, in aerobic condition, O2 air, we can just give it heat 180 degrees Celsius. So what will it give us? It gives us, this compound. Okay, so what is the name of this compound? That is our cumin hydroperoxide. Remember it correctly. Cumin hydroperoxide. Okay, now in cumin hydroperoxide we give it polypropionic acid or H3PO4 holane. That means chain of H3PO4. So if we just keep that, it gives us what? Two compounds. Two. Two compounds. What are they? One is our phenol and another is our acetone. So remember it very carefully. In the end product also, it gives us two final products, that is our phenol and our acetone. Next is our proper reactions of phenol. So first is our methylation, that is if we give it CH3OH NaI, so it will give us OCH3. So it is as methylation happened here. In acetylation, what happens that it forms a compound like this. Now what will be the uh, end product or major product from this? That is this bond gets broken. Okay, and it just will be added here like this. Okay, so that's how it is done, and it is our major product. Okay, because there comes a product that is para, so it is our major product here. Next is our chlorination. Now it is very simple chlorination. If we just give it this PCl5, it gives us chlorobenzene. Okay, now in the reaction with P2S5, that is in, it gives us this compound SH. Okay, in place of OH. Okay, next is our nitration. Now nitration is very easy because we just have to give it concentrated HNO3, concentrated H2SO4, and we know that it is a orthopara directing group OH, so it will be added like this. Okay, so what is this called? This is called our picric acid. You have to remember it because it is a very important reaction. It is called picric acid. So there is two important reaction, very important. That is a Raymer-Tremor reaction one, and next we will be reading, that is our Kobler's reaction. So let's see first Raymer-Tremor reaction. That is, if we give it this reagent, that is CHCl3KOH, what it gives us? It gives us salicylaldehyde. So what is salicylaldehyde? That is one CHO will be added in ortho or para position of our phenols or OH group, that is will be our called salicylaldehyde. So it is our salicylaldehyde. Now this is major product. There is also a minor product, that is where the CHO will be added in the para position. Okay, so here, but here there is a characteristic, that is in this reaction there is formation of carbene. Now what is carbene? That you can see in our carbocation, carbanion and carbene video. Okay, so let's see next reaction, that is our Kobler's reaction. So what is Cobbler's reaction? That is, if we react it in the first step with NOH, but you know that it gives us ONA, right? Now, in second case, we have to, we will write it like this, minus plus, because it is metal, so it will be plus. So in the next case, very important reagent, that is CO2, 140 degrees Celsius heat and 6 to 8 atm pressure. What it gives us? It gives us salicylic acid. In Reimer-Tremor, it gives us salicylaldehyde, and in Cobbler's reaction, it gives us salicylic acid. Okay, so here it is also major product. So you can guess what will be the minor product. That is, if COOH will be added in the para group. Okay, so next is our oxidation. So for oxidation, we take it K2Cr2O7 H2SO4. Okay, so it gives us, this. Okay, now there is identification reaction of phenol. That is, we react phenol with neutral FeCl3. Now you have to remember this neutral word very carefully, because sometimes they give you option is only FeCl3, neutral FeCl3, charged FeCl3. What is it? So the correct option will be neutral FeCl3. Okay. So what will it give us? It gives us FeOC6H5. This is our 5 whole 6 minus 3 plus 3H plus 3HCl. Now you have to remember this compound, because they sometimes ask you in the question what will be the product of this reaction. So you have to write or mark this compound here. So its color will be violet. So if the solution becomes violet, so then we can just guess it from that, in the reaction or in the solution phenol is present. Okay, now there is solubility. Now in solubility case, we can just say that if we increase the number of OH group, okay, here in ortho, para or meta position, the solubility will be increased. So if we see how will be the solubility, that is, the para group will have the most of solubility, then the ortho group, then our meta group. Okay, now acidity. Now as we know, acidity is directly proportional to minus I and inversely proportional to our plus I effect. So we have to just see that if it has minus or plus I effect, and that's how we decide the acidity. Now let's see an example, that is this will have more acidity than this, because as you can see, the group added here is NO2, which is a minus I group, and here it is a plus I group. So acidity is more than this group. Okay, so that's how we decided, and here is our phenol is done.